Hey there everybody, so we've been talking about angles a whole bunch up until this point, and now we're going to talk some about triangles. Let's do our I can statement for today. It says, I can understand the properties of the angles and sides of triangles. So in this blank, let's write angles and sides of triangles and the conditions for the existence of triangles. So you're going to write existence in this blank right here. So basically, you know what a triangle is, but we're going to talk in even more detail about exactly what makes up a triangle in today's lesson. So first of all, there is no worksheet for today. This notes page is just what you are going to turn in. If you don't have a printer, totally fine. Just write down the answers and take notes that are helpful for you. You do not have to write down every word on this page, okay? I don't want you to waste your time. Certainly not all of these instructions. You can just write down the warm-ups, write down the answers to these problems. The thing that we wind up writing right here, make sure you write that down. We'll get to it in a second. So just make notes on what is helpful to you. Okay, so let's get started with some warm-ups. Warm-up A, what are supplementary angles? Those are two angles that add to 180. So one might be 100 and one might be 80, or they might both be 90, something like that, but they have to add up to 180 degrees. Warm up B, how many degrees are on one side of a straight line? Well, remember, if you have a straight line, you could think of it as being made up out of a 90-degree angle there and a 90-degree angle there, and 90 plus 90 is 180. Or you could think of it kind of like half of a circle, with the whole circle being 360 degrees. So half of 360 is 180. Either way, when you see a straight line, the number of degrees in that straight line, 180 degrees. Okie dokie. How about warm up C? Are the angles 40, 60, and 80 supplementary? Well, let's add them up. 40 plus 60 is 100 plus 80 equals 180. Okay, they do add up to 180, but actually these are not supplementary. Any guesses why? And the reason is because it has to be just two angles. And here we have three angles, because supplementary angles are always two angles. So I'm going to say because supplementary angles are always two, not three adding to 180. Okay, there we go. Now part D, write an expression. Sorry, there should not be a D there. Write an expression that shows that a jacket was on sale for 15% off. Okay, so this has nothing to do with angles. This is just a little bit of helpful review. So how are you going to write an expression that shows a jacket was on sale for 15% off? Okay, first of all, let's choose a variable to represent the price of the jacket. Let's just call it X. So X is the price of the jacket. It might be $20, it might be $100. I don't know. Now we're going to subtract the amount of the discount. Now how much was the discount? Well, it was 15% of the price of the jacket. So in other words, 15% of X, because we're saying X is the price of the jacket. So to write 15% of X, we need to first transform that into a decimal, which is 0.15, and then multiply it by X. And then that's your expression. Notice it doesn't say equation. If it said equation, we would need like an equals sign and everything, equals equation. For an expression, it's okay for it not to have an equal sign. So X minus 0.15X. There is another way. If you came up with this, you could definitely do it this way. This is an excellent way to do it also. 0.85 times X is the same thing as this. Just think of it as you're doing the subtracting on the front end. So you're taking 100%, subtracting 15 from it, and you get 85. Turn that into a decimal, and you get 0.85, and you still have to multiply it by that original price of the jacket. Both of these are perfectly good answers. Okay, so now here are all these instructions for as if this were like a group activity in a classroom. But we're not in a classroom, so instead I'm just going to show you on my desk how to do the activity. If you would like to do the activity with me, go ahead and grab a ruler and a pair of scissors and a piece of paper and cut out a triangle. Make sure it has nice straight edges, because that's going to matter with this experiment. And if you don't want to and you just want to watch, that's okay too. But if you want to make your own triangle, go ahead and pause it now. I'm going to show you mine, and I'm so sorry about my phone. All right, I made a couple of triangles. Let's zoom out a little bit. So I made a nice green triangle here, and I made a little pink triangle here. Let's do the green triangle first. Okay, now you can just watch, or if you have your own triangle, you can do it with me. We're going to tear off the corners of our lovely triangle. Make sure you tear them long enough. You want it to be kind of as long as your thumb or so. So I'm just going to tear that off. There's my A. I'm going to tear off my next one. There's my C. And I'm going to tear this one off. There's my B. Okay, B almost got too small, but I think it'll be okay. Okay, now we're going to put all the points together, kind of like you're making a pizza out of them, except it's not going to make a whole pizza. We're going to put the points together. You can do them in any order. It does not matter. So I put that point to that point. And now let's take C and line it up also. And look at that. They kind of come together nicely, don't they? Okay, let's just push this out of the way. And let's do the same thing with our other triangle. Now this one looks completely different. This one has that obtuse angle. This is a scalene triangle. All the sides are different lengths, but we're going to do the same thing. Let's rip off those angles. Make sure you get big enough chunks. All right, there's my B. Gosh, how am I going to do this? For A, I'm just going to do it like that. I think that'll work best. And then for C, I haven't done this before with this particular triangle, so let's see how it comes together. Okay, so there's A. Now let me put that point together with point C. You could put it with point B too, it doesn't matter the order. And then still building my pizza, although this really doesn't look like a piece of pizza, I know. Still making that, they kind of sticking together on me. Okay, there we go. My B's upside down, but we're not gonna worry about it. All right, so we have two different triangles, corners ripped off and stuck together. What do you notice? What do those three angles of the triangle come together and make when you rip them off? Kind of lines up with my ruler, doesn't it? Are they both making a straight line? They are. So could we make a conjecture about how many degrees are in the three angles of a triangle if you add them all up? Yes, we could. How many degrees are in a straight line? 180. So how many degrees will be in the three angles of the triangle when you add them all together? 180. Definitely. All right, I'm going to push this out of the way. Let's get that notes page back. Don't know where I put it. Oh, there it is. Okay. So looking here, it says, what conjecture, in other words, educated guess. It's like a hypothesis in science, right? What conjecture can you make about the angles in a triangle based on your observations? You can guess or conjecture that they add up to 180 degrees. And just make sure you're writing this down. They add up to 180 degrees. That's the important part. This is also, by the way, called the triangle sum theorem or the angle sum theorem. Anytime you have a triangle, the three angles in it are going to add up to 180 degrees. Okay, so now let's use this triangle sum theorem to do a few more examples, and then we're going to get back to our scraps of paper in just a minute. I'll see if I can keep my desk a little bit neat and tidy. So problem number 1 here. Can you make a triangle out of the following angles? Why or why not? Okay, so what we're going to do here is add them up and see if they equal 180. Are you ready? 40 plus 60, that's 100, plus 80, that's 180. So if you add them up, they're 180 degrees, so the answer is yes. Let's do the next one. 10 plus 30 is 40, plus 50, they equal 90 when you add them up. So that one is a big fat no. You cannot make a triangle out of that. And if you got out your protractor and tried to, you would see that it just doesn't work. Like you'd have a narrow little angle here for the 10 degrees, and then a narrow angle here for the 30, and then the 50 would go that way. It just doesn't work. What about this one? 50 plus 50 plus 40, let's see. That's 100, then we get to 140. So that's a no also, isn't it? Because it does not equal 180. What about 90 plus 90 plus 90? Let's see, we get 180 there, and then it goes all the way to 270. So that one's a no. What about 30 plus 60 plus 90? Let's see. 30 plus 60 is 90. 90 plus 90 is 180. Oh, yay, we got another yes. All right. What about 100 plus 80 plus 0? Oh, okay, so this one's a weird one here. They do equal 180, but can you have an angle in a triangle that measures 0 degrees? It doesn't really work. It's like it doesn't exist that way, and it wouldn't work if you tried to draw it. A 100-degree angle is going to look kind of like that. And then an 80-degree angle there would be kind of like that. And you see the lines, they don't come together. They don't form a triangle. And the answer is no. Because of that 0 degrees. You can't have a 0-degree angle in a triangle. It has to be above 0. Okay, let's look at example 2. Here it says 2 of the angles of a triangle are given. What is the third angle? Show your work. All right, so you have 2. You don't know what the third one is, but you do know that they add up to 180. So let's set up some equations. So we're going to add these together. 10 plus 100 plus x, that's our unknown, that's our third angle, and then put equals 180. And then you just have to solve your equation. So combine these like terms here. You get 110 plus x equals 180. Subtract the 110 here, and you're going to get x equals 70. Okay, let's try this one, 60 and 60. This time I'm going to make it a little faster just by combining these ahead of time. What is 60 plus 60? It's 120, right? So let's just say 120 plus the unknown, the x, equals 180. Subtract your 120, you're going to get x equals 60. Okay, let's do the next one. 50 plus 40 equals 90. 90 plus x is going to equal 180. So subtract 90 from both sides and you'll get x equals 90. Totally fine if you want to use a calculator for these, especially as we go to the next 3. I might grab it as well. So 43 plus 88, let's combine those. 43 plus 88, looks like that's going to be 131. And plus x equals 180. Now you're going to subtract 131 from both sides. So I'm going to do 180 minus 131. And that gives me 49, and that's my missing angle. X equals 49. Let's do this one. 24. Oh, I forgot. I'm just going to do that on my calculator. 24 plus 117. 141. Okay, so 141 plus x equals 180. Now you're going to subtract that 141 from both sides. So you're going to do 180 minus 141. You're going to get 39. So this time the missing angle is going to be 39. And if you're ever unsure, you just take them, you add them all up together. Let's do that now. So you would do 24 plus 117 plus the number you solved for, 39 in this case, and it should equal 180. And it does, yay, so we know that we're right. Let's look at that last example. 153 plus 10. Well, that's going to equal 163 plus x equals 180. Grab your calculator and subtract. I'm pretty sure you're going to get 17. Let me just double check. 180 minus 163 equals, yes, okay, so 17. And that's how you do that. Okay, let's have a little bit more fun with these papers. But first, we're going to talk about a couple definitions. Congruent is the geometry word for exactly the same, like equal. So congruent shapes are exactly the same size and shape, but they're not necessarily oriented in the same direction. Let me show you an example after we finish writing this word. So they're not always oriented in the same direction. Okay. So what if I have, there's my little background paper, I have these two triangles. I have triangle ABC and then another triangle ABC. These guys are exactly the same. Can you tell they're the same? If I put them on top of each other, you can, oh my gosh, I cut them out together so they are exactly the same size and shape. The angles are the same, the sides are the same, everything is the same. But would it be okay if I oriented them differently? Yeah, they're still congruent. What if I even flipped this one over? Are they still congruent? Yes, they are. There's nothing you can do here, twisting, turning, flipping, that makes them not congruent. They'll always be congruent unless you come along with your scissors and make a little change there. That would definitely make it not congruent anymore. All right, so back to our notes paper. Similar figures. Okay, this is bold. I know this is like a really common word for us, but it's also an important math word. So congruent means equal. What does similar mean? Similar figures have the same shape, but they are not the same size. Similar figures can be smaller or bigger than one another. Okay, so yeah, they're not the same size, but they are exactly the same shape. So don't worry about this. I mean, you can certainly do it if you want to, but you can see it's kind of adapted from a group activity. So let me show you our version of this. I'm kind of excited about this. Hopefully it works out. Hopefully I cut my triangles neatly enough. Okay. Now we've talked about these two triangles. They are exactly the same. They are congruent. So I'm going to rip the angles off of one of them. I'll do this one. Use the lucky triangle. Gonna get all ripped up. So there's angle C. Let's get angle B kind of carefully ripped off of there. Okay, there's B. And then what's left of A. There we go. So just for fun, let's line them up and make sure that they form a straight line. I'll just do it here at the bottom. There's B. There's C. And then make sure you go with the unripped sides, go with the cut sides, put them all together, and oh yeah, that's beautiful. They definitely form a straight line. But that's not actually what we're doing here. Let me show you what we are doing here. Can we use these three angles to construct a new triangle? Well, yes we can. Here's what we're gonna do. We're gonna start with just a line. So grab your ruler if you're doing this along with me, and if you just wanna watch, that's fine too. So I'm gonna just draw a base right here. Doesn't really matter how wide it is, I'm just guesstimating. And let's see, I'm going to put angle A here. Whoops, it's kind of hard to line up. They always want to stick to my fingers. And then B, I'm going to put him right there. Just like that. Okay, good. So now I'm going to draw like lines along the side of that. So, okay. That's lining up nicely. Let me just kind of trace along here. There we go. Get rid of that one. I'm going to go ahead and write a B on it so I remember what I put there. And this one I'm going to trace right along here. Okay, there we go. And that one was A. Now what I'm going to do is I'm going to grab my ruler and extend these lines, extend them up so that they cross and make a triangle. So it's okay if I draw a little too long. We can always like scribble out the extra, but I'm going to start with this B. Okay. Okay, we're just going to take it all the way up to there. And let me zoom out so you guys get a better view. Okay, and now we're going to extend this line that we started with angle A. I really hope it fits on my paper. It's not going to fit on my paper. Oh, man. I should have started it out lower. Well, I'm going to just get another piece of paper and put under it, I guess. Yeah, I think that's what we're going to have to do. Actually, you know what? I'm going to just flip it over and start again, but I'm not going to make all you guys watch this. I'm going to pause. Give me a second. Okay, here we are on the other side of the paper. I've just started the same way, but I made this line a little shorter and more towards the bottom. We're going to try this. If you guys are doing this along with me at home, I hope it's going well for you. Okay, so I have it all lined up, and I'm just going to take my line straight up to the top. And now let's get our other line. So, lining the ruler up with this little short thing here. About like that. Oh, it's going to work. I'm going to have to move my ruler just a little bit, but we're going to get it on the paper, and that's the whole goal right there. Okay. It's almost going off the paper. My goodness, this is a long, skinny triangle. Okay, perfect. So this was angle B, this was angle A, and this one is going to be angle C. So let's grab our angle C and see if it actually fits. Yeah, that fits really nicely. And that's good. But that's not actually the point of this. The point of this is to say, well, let's zoom out so we can actually see this giant thing. It's not going to zoom out anymore. Okay, we're going to just do it this way. Wow, this is a big triangle. This is such a fun video. Okay, hey, we can see the whole thing. Fantastic. All right, so now we used these three angles cut from a triangle that was exactly like this one. It was congruent to this one to make this whole thing. So are these two triangles congruent? No, because if they're congruent, they have to be the same, like equal, and this one's huge and this one's small. So no, they are not congruent. But are they similar? Well, kind of don't look the same, but what happens if I flip this over? Because notice down at the bottom, I put angle B on the left and angle B on the right. I did that on purpose, by the way. And here we have angle A on the left, so we need to match up the angles. So A is now on the right and B is on the left. And remember, you can flip it around and it's still congruent. Actually, yeah, congruent, that's the word, sorry. Now, can you tell that they're exactly the same shape, except this one is smaller and this one is much, much bigger? And if you were to stick all the angles into the corners, you would have exactly the same angles. So the whole point of this experiment here is to show that if you have the same angles in two different triangles, they will definitely be similar. They might also be congruent if you happen to get the side lengths exactly the same. But the same three angles definitely means similar. In fact, I didn't really even use angle C. You can toss that one out. You could have used angle B and A alone, remember, to make the bottom two and then cross at the top, and you already had a similar triangle. So really, all you need is angle, angle to get similar triangles, and that's what we're going to write at the bottom here. So back to our notes page. We are going to say, and now I'm like way out there, so let's zoom in a little. Looking at the very bottom question, it says, if you have the same three angles as someone else, basically it was a group activity, just go with it. If two triangles have the same three angles, what can you say about the triangles? You can say that they are always similar, always similar. You cannot say that they're always congruent because one might be bigger and one might be smaller. And the name of this theorem is the angle-angle theorem, AA, angle theorem. Basically just saying that if you have two identical angles or like congruent angles in two different triangles, if two of their angles match, the two triangles have to be similar. And that's called the angle-angle theorem. You don't have to worry about that on this test. It's something that you'll learn more about as you get older and do more geometry, but just know that two angles the same or three angles the same will make it similar. Okay, that's the end of this video. Remember, this page is all you have to submit. And thanks so much for watching. Let me know if you have questions. See you next time.